consumption, those kind of things. So well, let's explore it a little bit more. First of all, once we started talking about production, we use units all the time, and the units that are most often used are not kilograms or grams, and most of the time we use moles or molars, which is actually a measure for the number of molecules in your solution. And you can convert grams to moles and moles to number of molecules based on these formulas. So if, for example, you want to have 1 mole of sugar, that means that you need 6 times 10 to the 23rd number of molecules. So it's a pretty large number, but that number of molecules is 1 mole. And if you want to know how many grams 1 mole of sugar is, then you have to multiply it by the molecular weight. And the molecular weight of a molecule, now we're getting really interesting stuff, is of course derived from the periodic table. So yes, finally we're there. Real chemistry. We thought it was going to be about biology, but we're just going to talk about chemistry now. You still remember this from high school? Yeah. So, do you remember how to read this this table? Yeah. Now, the most important thing for us as a biologist is the atomic mass of an atom. So, how much does it weigh, basically? And in a typical periodic table, that is the number that's on the top left of the square that the element is in. So, on the top left, there's helium, for example. No, not helium, hydrogen, sorry. Helium is on the top right. Hydrogen, and hydrogen weighs 1 unit of molecular weight. That's yeah, you see carbon somewhere over there in the 14th column, and then nitrogen is right next to it. Oxygen is right next to that. So you can find them over there. And if you want to then calculate the molecular weight, for example, of water, you take that table. You know, of course, water is made out of 1 O and 2 H's, H2O. And to calculate the atomic weight, you say, okay, I have 2 pieces of hydrogen, or 2 atoms of hydrogen, 1 atom of oxygen. And the molecular weight, you can get it out of the table. Well, hydrogen is 1 and oxygen is 16, actually 15.9, but okay, 16. And then, yeah, from that, from this formula, then you know that molecular weight of water is 18. So if you want to know how much is the weight of 1